Welcome to qnawire.
Welcome to the problem number 22.28. This is chapter 22, course law. So this question is very interesting. So we are given that there is a square insulating sheet having 80 centimeter side. So this is A, A. So this is a square having 4.5 nanocoulomb charge on this. So this is uniformly distributed over this one. So this whole sheet of charge having Q charge and the uniformly distributed of this one. So first we need to find out the electric field at distance d equals to zero point 0.1 millimeter and at distance 100 meter. These ranges are very important here. So first we have to understand that for this d, so d is equals to zero point 0.1 meter, 1 millimeter. So this is equals to zero point 0.1 into 10 to the minus 3, or you can say 10 to the minus 4 meter. So this is a very small. So this is a very small point. So if you try to make it on the axis, so let's say this is sheet, this is my sheet having a side having q charge uniformly distributed. So my sigma, the surface charge density would be q over a, which is q over area of this sheet, which is a square. So this would be my sigma. And for the distance d equals to 10 to the minus 4 meter, and looking at this one, so this side is 80 centimeter. So if I try to find out the point d, so this is a very small, maybe you can say that this is almost on the sheet. Now for this point, so this sheet looks like an infinite sheet of charge. So for this d, for this distance, this finite sheet of square side 80 centimeter looks like a infinite sheet of charge, because the distance between this sheet and the point is very small in comparison to the size of its own sheet. So we can use the electric field due to the infinite sheet of charge, which has sigma charge density. So we can find out the sigma here. So my electric field at that point is independent of distance. So this would be sigma over 2 epsilon naught, and sigma is equals to q over a square. So we put it to e naught a square. Now a naught is our zero point 0.8 meter and e naught is our 8.854 into 10 to the minus 12 coulomb square per newton meter square. So we have putting all these factors here. So E becomes 4.5 nanocoulomb, which is 10 to the minus 9 coulomb, over twice of 8.854 into 10 to the minus 12 times zero point 0.8 square. So calculating this using the calculator, so this comes out to be equals to 397 Newton per coulomb. So this is your answer for A part. Now going to the B part. So for now we have distance equals to 100 meter. So looking at this distance 100 meter and the sheet has zero point 0.8 meter size. So that means this point, for this point the sheet of charge looks like a point charge. So which has Q charge, and this is the point where we are finding out the electric field. Now the D is 100 meter. For this distance, sheet appears or looks like a point charge. So charge is conserved, so we have electric field due to point charge, which is equals to Q over 4 pi epsilon naught over R square. So we have electric field equals to 1 by 4 pi epsilon naught Q over D square. So we know that 4 pi epsilon naught is 9 10 to the 9. So our Q is 4.5 into 10 to the minus 9 coulomb. You can take care of the units later. And D is our 100 meter, so we have 100 square. So this comes out to be 4.05 into 10 to the minus 3 Newton per coulomb. So this is your answer for your part B, and this is your answer for your part A. So that's all for this question. But we have another question. So the question here is the C part. So the question is, if the insulating sheet of charge which has uniform charge distribution of Q, if replaced this one with conductor with same charge, what would the difference would be? So if it is a conductor, so the whole Q will distribute over the whole sheet. So this would be the same situation as it is insulating. So the answers will remain same because the distribution of the charge is the same. So both situations are same. So we have the same answers. Same answers for part A and B. So that's your answer for this question. Thank you for watching the video.